Hello and welcome to my course Android Programming with Kotlin for Beginner. In this course we are going to create a calculator app, and in this introduction I'm going to show you step by step what are we doing, why do we do it, and at the end of this introduction I'm going to present you the app we are developing in the next lectures. So first, we are going to talk about Android Studio and the actual Android framework. So how to create a project. We're gonna set up a new project step by step. Then we are talking about activities, fragments, and views. So you will learn what are activities, what are fragments, what are views, when to use which of them. Then we are going to learn how to create a custom view. So we are creating our custom views that are displayed inside the calculator app, and how to lay out a view in a constraint layout. So it's not that easy like in a linear layout or a relative layout. That's why we are going to take a lecture for the constraint layout. Then we are talking about the model view presenter architecture. So what is model view presenter? What are the advantages? When to use? And at the end we are doing a practical implementation of model view presenter in our Android app and write some simple and basic unit tests. So that's it. That's a short overview of what we are going to do in the next lessons. And now I'm going to show you the app we are developing. So this is the app we are actually developing here, the calculator app. I can open it, and in there you can see we have the numbers, some symbols with basic logical calculating operators, and yeah, we can type in some numbers and do some basic calculation in there. Great. We also have a landscape layout for this application, so with the operators or the operation block on the right side and the visible view part, which are displaying the equation and the outcome on the left part. So this is the app. Yeah, like I said, you could do some basic logical operations, remove numbers, add numbers, and so on. This is what we are going to develop completely together from the first lesson to the last lesson in this course. And yeah, you will learn some basics about Kotlin, some basics about the Android framework and in general Android developing. And at the end, you will have this cool calculator app that you build by yourself. So hope to see you again in the next lecture. Hope you like this course, and yeah, just try it. Let's start. Now we're gonna create a new Android Studio project. Just download Android Studio, install all required components, and then you should see a window like this here. Welcome to Android Studio. And then we're gonna click on Start a new Android Studio project. You have different templates right here. You can just create a basic empty project with nothing, but we want to have an empty activity in this. So we're gonna select empty activity. Click on next. Then we can say we can set the name of our application. In this case, we're just going to call it calculator. And right here you can set your package name. Package name is normally your company or your domain. Like my domain is com.fragmo or fragmo.com, but you're going from last to first. So com.fragmo.calculator is the actual package name. You can select, for example, com.abc.calculator, whatever. You don't need to have a domain for this. So if you don't have this domain, fragmo.com, for example, it's not required. You don't need to have this. You can also just call the package name whatever you want. Then you select a location where you want to save your project. As language, we gonna select Kotlin, and as minimum API level, we gonna select API 21. So this is the minimum API that is supported. So means all Android devices below Android 5.0 are not supported for this app. So like here you can see how many % of all listed devices in the Play Store are running your app, and yeah, 58% is enough. If you would select, like for example 4.0, every device listed on the Play Store already has this Android version. But we're gonna continue with Android Lollipop, so Android 5.0. Then we're going to click on Finish, and a new project is created. I'm gonna move it right over here if it's possible. So right now we have our project. It's still running, like you can see here. Just wait until it's done. It's doing some Gradle sync, some project in its steps. So we're just going to wait until this is done. So looks good so far. Looks like we are done. We have one activity, the main activity, and here is our manifest file, like I talked, or I will talk in the next lecture about this, or in one of the next lectures. But here you can set your launcher activity. So this is the main activity. This is the layout for the main activity. But what we are going to do right now is to migrate to Android X. So you're gonna select the menu on the top, click on Refactor, and then click on Migrate to Android X. We don't need to back up the project as a zip file, and then we can click on Migrate. So then we're gonna click on Do Refactor below here. Changes detected, rerun search. Looks good so far. Looks like we are already on Android X. I don't know if he has actually done something. But yeah. So this is the Gradle file. We talked about that. We can talk about that right now. You have your Gradle files in the app module, where you can set different dependencies, like external libraries you want to use. For example, in our case, we use some Android library versions. You can see here a new version is available. Then you click the Option key on your Mac and the Enter key, and then it's gonna open this menu where you can select Change to 1.1.1. I don't know which key it is on Windows, but on Mac it's the Option and the Return key, the Enter key. And this is opening this menu, and then we can update the dependencies to the latest version. Then we can click on Sync Now, so the Gradle is synchronizing the project and downloading the latest repositories. So now we're going to make this file look a little bit better, a little bit nicer, and you can see more. We're gonna add some comments. This is for Kotlin. This is the Android framework. And this is for testing. We actually don't need Espresso, and we don't need this one. We can remove them. We have the constraint layout, the core, and the app component. That's all. So what we are going to add as a testing dependency is Mockito. Mockito, I will talk about that later if we are in the lecture for testing. But Mockito in general is a mock library that can help you to test your classes. Now we gonna click on Sync Now, and looks good so far. So we have a good looking Gradle file, we have our main activity, we have in the resource file, the resource folder, we have our activity main file. And yeah, so we created a new project, the calculator project, and that's it for this lecture. And we're going to continue with the next lecture. See you, goodbye. Hello and welcome back again. In the last lecture, we just created the Android Studio project. We created that manifest file over here, the main activity, which is empty right now, and the main activity layout with a constraint layout and a text view, which was added by default to the activity. So, but that's it. That's what your project should look like right now. I can open the Gradle file. We also did some changes there. Yeah, just make sure your project is equal to this one. And now we can continue with importing some resources you need for this project. You can download the calculator app zip file directly here below this video. Then you can unpack it and open it. So there is a logo for the app and some icons you will use later. So how do we import this into Android Studio? You can just type in open in your terminal, and then it's going to open your project folder. You can also just go here through where your project is actually saved. Let's use this view here. It's the best. So in repositories, then the calculator project, and then you should be in the root directory of your project where your project was saved. Then you click on app, on source, on main, and then on resource. And this is the drawable folder. It should be empty right now. And now we are going to add all of these elements here. Just move them into this folder. So if you go back to your Android Studio project, you should see that these files should be imported. And in the preview here, you can see that these XML files are actually icons that you will use in your calculator app. So what's now missing is the launcher icon. We can click on new and then image asset. Then we are going to select our calculator logo, select this one. Then we are going to resize it so it's fitting. I think looks good like that. We are setting the background color, use color here, select white. So I think that looks good so far. This is our icon, maybe a little bit smaller. So that on the round icon, the logo is still visible completely. Looks good so far. So we created, we are there to create the launcher icon. Click on next, then click on finish. So that should have worked right now. And if we click on the IC Launcher foreground, there should be this one perfectly. And we need to just open the foreground for version 24. I don't know why. This might be a bug in Android Studio, but it's not creating this one correctly. So just select all, copy, and then paste it here. So you have the correct icon. If you open the My Map folder, there should be the correct launcher icon in there. And yeah, that's it. Now we imported all required icons and created a launcher icon. And yeah, we will continue with the next lecture. See you and goodbye. Hello and welcome back. In this lecture we're going to talk about view creation and layouting and answer the basic question, what are activities, fragments and views? But first I'm going to show you an Android manifest file. Every Android project has its own Android manifest file where all your activities are listed or need to be listed, because if you don't list your activity here and launch it, your app is going to crash. So always list your activity here. But one activity is different from the others because it has an intent filter with the action main and the category launcher. What does that mean? That means if you're on your home screen, at the home screen of your phone, and then click the application icon of your app, then the application is looking, which activity should I start first? And then it's looking for the flags action main and category launcher, and is launching the activity that has these flags in its intent filter. So only exactly one activity can have these actions, and this activity is started first when you launch your application. So this is where to set which activity should be started first. Now we're going to continue with activity, fragment and views. In general, what is an activity? An activity is a frame that can contain fragments and views. A fragment is a frame that can contain views, and a view is everything visible on the screen. Just like an image, a text or button or whatever, everything visible inside an application is a view. So when to use which? I like the metaphor of a skyscraper, where activities are the different floors of a single house. Fragments are the different rooms. You can have different rooms on your floor, but it's not required. You can also just have one big room. It doesn't matter. You can do both. And the views are the furniture inside a room or floor, which are actually visible, and yeah, you can see them. When to use which? It's not that easy to exactly say when to use a new activity and when to use a new fragment. With the time, you're gonna know when to use which. But in general, just like a really basic rule, you can say, use a new activity if new context has nothing to do with the current context. So for example, if you have an activity that is listing some files on your device, and then you want to show a detail page of a specific file, then this detail page has nothing to do with the list. So you're going to start a new activity and display the detail page, and do not use a new fragment. Use a new fragment if new and old context have things in common. Best example is paging. For example, if you have one activity but have different pages inside this activity, page 1, 2, 3, whatever, and want to page between these, then you're going to use one activity but different fragments because these pages have something in common. And yeah, views are pretty much different from fragments and activities, because fragments and activities, like you already learned, are containers, and views are actually visible elements. So use views to display something inside activities or fragments. And yeah, you can also have custom views where you can customize everything, but yeah, views are the things that are actually visible inside your app. That's it about the basic question, what are activities, fragments and views, and when to use which. I hope you got a little understanding about what are these three things, when to use a new activity, when to use a new fragment. And yeah, we're gonna see each other in the next lecture. Bye. Hello and welcome back to the next lecture. In this lecture we are going to create our first custom view. We're gonna create the view that is on the top of the calculator, where you can see your equation, your current equation, and also the result or the outcome below the equation. So first we are going to create a custom layout. Just go to your layout folder, do a right click and click on layout resource file. Then we are going to call this view calculator output. The root element should be a linear layout, and the rest is okay like that. So what is a linear layout? A linear layout is a parent, a view group parent, which means that you can add views to a linear layout, and they are listed below each other or next to each other. I'm gonna explain that to you in a second. Just type in text view, then layout width wrap content, layout height wrap content, and then just close this tag, so it should look like this. Now I'm gonna copy the actual text view to this one here. Just import this one again, press Option and return. And now I'm going to explain you what these attributes here mean and why we need them. The first one is the ID. For example, if I copy this one again and paste it, it's displaying an issue or an error that this ID is already defined in this layout. So what does that mean? You can have two identical IDs in one layout. So it means this ID is unique in this layout, and so you can say if you type in this ID, it's definitely this text view, and we need that in code to update the text for this text view, for example, or general to do something with this text view, and so we can find it in code with this ID. Then layout width and layout height, it's almost self-explaining. The width is how long this text view is. You can use wrap content. Wrap content means it's just as wide or as long as required. If we type in match parent, it's going, like you can see the preview here. If it's not visible, just click here on the preview. It's going above the whole screen. But we only want it to be as wide as required, so we just use wrap content. For the height, there is the same. Now we can see it's going from the top to the bottom, and now it's just as high as required. Layout gravity, what does that mean? Layout gravity means where in the layout should this view be displayed. If we type in start, for example, it's gonna be on the start of the layout. If we type in center, it's gonna be centered inside the linear layout, and so on and so on. So we want it to be on the end. Then the gravity is inside the text view. That means that the text gravity is on the end. So it's like, how should I explain that to you? The text is starting on the right and is typed from right to left. So new text is added on the left side, for example. It's not that correct. The new text is added on the right side, but the text view will always stay on its position and will expand on the left side. So if new text is added, the whole text is moved a little bit to the left, but it's still aligned on the right side. Yeah, I don't know if you got that, but you will see later. Max lines means the maximum lines this text view can have. So in this case, it's 3. So means you can only have 3 lines in this text view, and if it has more than 3 lines, the text just gotta be cut off. So we don't need more than 3 lines. That's enough. So that's why we had this one here. What is padding? Padding is like a spacing inside the text view. If I remove this one, you can see it's actually just as large as required. And if I now add a padding start, for example, with 16 pixel, you see there's a small space on the start. If I add a padding on the end, you can see a spacing on the end. And if I just type in padding, it's gonna make a padding on the whole view. So above, on the left, on the right, and below the view. Then the text color. I don't know if we actually need this one. Color text. Just add a new color if I haven't already explained to you. I don't think so. So just open your values folder, open the colors file, and just add a new color by typing color, then call it color text. I call this color text A because I can't call it color text again. Then just define this new color, just like this. And then call this color text. And you can also add this new color text light. Just copy these values. It's A0, A0, A0. and this one is just 0. Yeah, and then just type in, oh, that's not what I wanted. So an add and then color slash, and then there should be already some colors that are available displayed, and then you can say color text. Android text size. Text size is the actual text size. How large will the text be? What size will it have? Then for this one, we're going to open the dimension file. If you don't already have a dimension file, just right click new value and then type in diamond. And then just click OK. In my case, it says file already exists because I already have one. But you can just create a new dimension file and then just add the text size calculator equation and text size calculator outcome. And just make this one 32 SP and 24 SP. So if you have done that, you can just, like I did before, just type in an add diamond slash, and then you already see all available dimensions, and then we use the text size calculator equation. So what is that tool text for? Tools these are real Android attributes. So it means all of these attributes are actually applied to the view. But these tool attributes are just for the preview here. So it means these have nothing to do with the actual text view. So in the actual app, this is ignored here. This is not, I don't know if it even is compiled, but it's definitely ignored. So means we can just use this one to display something in the tools. So if we remove this one, you can see there's no text in it, so we couldn't see, oh, how does it actually look like? And that's where we add tools text. And then we can add a text, but this text is just there on the preview and not on the actual app. So if you open the actual app right now, this text view will be empty. There will be no text because this tools attribute here is not used in the actual app. So next one, in the next step, we are going to do the same thing again. Just add another text view, or we can remove this one. It's not required. And yeah, just give it another ID, also wrap content, wrap content. Gravity is again and add background. We just add null. Oh, we don't need that one. Just remove it. Sorry. Max lines is 1 in this case, so the result view can only have 1 line. Padding again 16 pixel. Text color and text size. We already did that. And tools text in this case should be 49. So now your layout should look like this. And now I can explain what this orientation attribute here means. In our case, it's vertical. If I would now set it to horizontal, that would mean that the views are listed in a horizontal way. So next to each other, next to each other. And if I type in vertical, all views are vertically listed below. So if I would add another one, it would be added here and so on and so on. And in the horizontal case, the views would be added here, but no new line. They would just be added here, and the next one would be added outside of the screen so you couldn't see them. But we will use a vertical linear layout, so we have this one. And this looks good right now, I think. Now we are going to create our actual custom view. This is just a layout. We have not used it yet. Just open your folder, click on new, Kotlin file class, and then we type in calculator output view, and just use file. Okay, then we type in class, oh, not here, class calculator output full extends frame layout. Frame layout is just a really basic view group where you can add another layout, and of course we add here context and attribute set. So this attribute set is nullable, which means null can be passed for this parameter here, and this is not nullable, so this actually needs to be a context, and this can also be null. Now we can pass our constructor parameters to the frame layout. So great. Now we are calling the init method here is automatically called when the view is created or instantiated. So it means right now we are inflating our layout we just created. So we call layout inflator dot from and then context dot inflate r dot layout dot view calculator output. The parent is this, so the parent is the frame layout here, and then we say attach to root true. So it means it's actually added to the root. What we could also do is, well, of course we need to call this val view, and then we call false, and then we could say add view view. So this is another way. For example, if we want to do something with a view here, we could do it like this. So the layout inflator is returning a view, and if we say attach to root, it's not added to the parent, to the root here again. But so we need to manually add it. But if we just type in true here, the view is automatically added to this frame layout, so to the parent. So I think, is that all we need? Yeah, actually I think so. So right now, if I click on build, oh, this does not look like I always had it. I just made an Android Studio update, so yeah, that was it. And everything was a little bit changed a little bit, so yeah, that's why. But now it looks familiar to me. So right now, if we go to the main activity and then just add the calculator output view, just make it height width match parent and a height of 200 pixel. So we have an actual width. So the view is constraint. Yep, I know. Just add these constraints here. Just import it and add it. App layout constraint end to end of parent, layout constraint start to start of parent, and constraint top to top of parent. I'm going to explain that to you later if we are talking about the constraint layout in another lecture, but just copy this for now to place this view inside your layout. So, and in the preview you can see, oh, we have an actual custom view, the calculator output view, which looks like this. Great. That's how we want it to look like. But there's now one thing we can improve. What we are doing right now is having a frame layout and then adding a linear layout inside the frame layout. So the frame layout is actually not required. We just use it to add another layout to it, but we don't need that. So what are we doing? We are removing the frame layout and add a linear layout here. So we have a linear layout right now. Of course, what we need to do is we need to set, what I forgot. I forgot to add the Android gravity attribute here, and we want to do this center vertical. So means these are centered vertical, what you can see right now. Oh, just make this one a frame layout again, sorry. And now you can see that this is centered. Before it was not centered, the views were on the top and not exactly centered in this layout. So if I make this one 300 pixel, for example, it's still in the middle and centered, and that's what we want. So that's why we need this gravity attribute here. Center vertical, we could also use center in general, or is there anything else we can do? I think there's also start. Gravity is start, or it doesn't make sense right now. If I make gravity bottom, for example, the views would be aligned on the bottom. And if I click on build right now, you can see that now the views are not centered, they are on the bottom. But we want to have it centered vertical, just like this. And then, I don't actually need to build. Then you can see it's centered. Great. So now what I wanted to do is to remove this frame layout and just replace it with a linear layout. What we now need to do is we need to add two more steps. We need to set the orientation programmatically and the gravity programmatically. Just type in orientation and then vertical and set the gravity by gravity center vertical. So what we can do right now is we just make this one a merge. What does merge mean? Merge means that this layout has no actually parent and it's just directly merged. So all this views inside here are merged into the parent layout here inside this layout. So we are going to take all views of this one here, the text view and this text view, and add it to the linear layout. But you can see here in the preview, this looks kind of bad. Looks not that good because we don't know, the merge here does not know what layout the parent is. So what we can do right now is we can set tools gravity and we can say tools parent tag, and then we can say linear layout. So now the merge flag here, the merge thing here, knows the parent is a linear layout. And then we can say tools orientation should be vertical. So now the layout knows that the gravity will be set vertical, the orientation will be vertical, and the parent view is a linear layout. So now the preview can display it correctly again. So what we did right now is remove this linear layout here and just directly inflate the text views inside a linear layout. So we don't need an extra layer with the frame layout, which is actually not required. If we click on build here, you can see perfect, looks good so far. This is our calculator output view. This is our calculator output layout. And yeah, that's it for this lecture. We just created our first custom view. We see it here in the activity main. It's the view that is displaying the equation and the outcome. And yeah, so we are good right now. We're good for this lecture. And I'm gonna see you in the next lecture. Goodbye. Hello and welcome again. In this lecture, we are going to create our second custom view, the calculator input view. The calculator input view is actually a single view with, for example, the number 1, the number 2, or an icon with the delete icon, the back icon, the plus, the minus, whatever. So every input element, every input tile is an calculator input view. Just do we're not going to start with the view. We're going to start with the layout. Just go on the layout, new layout resource file, view, calculator, input, input. So view calculator input, the root element will be a relative layout. And then we can just click OK. So what are we going to start? We just add a view, make it match parent and match parent, so it's gonna fit the whole screen. And then we gonna set the background color. So just type in background, and then we are going to add a new color. I just copy this one, color tile background. So it's a new color. I already told you how to add this one. Just open your colors XML file and then just add this new color with D3, D3, D3. This is going to be the background color of a single tile. Then just say color tile background. So great. The next thing we are going to add is a image view. I will just copy it again and paste it, and then you can just copy this one from my screen right here. What we need next is we already created our dimension file, and then we are going to add a new dimension like this one, and we can also just add the second one we need, the text size input element. So this is a new text size. We already told about text sizes. This is the size of the icon with 24 pixel. So what we need right here is the width, and the height will be the size icon height. So means here we can see it's 24 pixel height. I see we also have a new color, the color image. So just open your colors file again, just add a color image, and this one is just color accent in our case. Oh, I don't know if I actually told you we need to update this color here. I think I did that in the project setup, but I'm not sure about it. So if I didn't do that yet, just adjust this color accent to E0, 8E, 3A. And color image should just link to color accent. So we should be good right now. Everything is here. Now I'm gonna explain you what does each attribute mean. We already know what Android ID means. We already know what width and height means. So the next thing is center in parent. If I would remove this one, you can see the view is added on the left side on the top. But we want to have it centered inside the view, so we use center in parent. We could also just use center horizontal. That would mean it would be centered horizontal in the view. And we can just use center vertical, then it would be centered vertically in the view. But we want to have it centered vertically and horizontally, so that's why we just say center in parent, and we say true, so it's centered vertically and horizontally perfectly. So the next one is tint. What does tint mean? Tint means the image is tinted with this color. So if we would use color, which one should we use? Primary, for example. You can see the image here does have the color primary, but if we use the color image, the image have this color we want to have it. The next one is tools ignore. Content description. You should not use that flag, but in this tutorial I'm gonna do this. What is a content description? So if I remove this one, you can see there's a warning, missing content description attribute. What is a content description? A content description is describing an image, so people with limited vision, like blind people or just people who can see, like most of us can see, want to use an app, and they touch on a text. They can, yes, a program can read what text is there. But on images, it's not that easy. So if he clicks on that image, he don't know, okay, what is this image? And that's why we use a content description. A content description explains to people with limited vision what you can see there. So like we could add a content description which says delete equation, for example. So he knows if he click on that icon, he's going to delete the equation. But we don't do this right here. That's why we add the tools ignore. You can also just press option and return. And then here's add suppress, add tools ignore content description attribute. So it's adding this one. So the last one is tools source. We're gonna add a drawable. We already added these icons here to the project. And then right now we are using these icons. We're actually not using it, it's just for tools, so it means it's just for the preview, because like you would see, or would not see, there's nothing, and we want to have something in the preview, so we set an icon for the preview. It's just used for the preview and not for the actual layout. So the next thing we are going to add is a text view. I'm going to copy this again. So looks like this. ID input element text, we already know this one. Center and parent, we know that one. The text color, text size, we already know. Now the text style is a new attribute. You can just set normal. Then it has the normal text style. You can set italic. Then it has this italic text style, and what we need is bold. So we set the text style to bold. And you already know that Android text attribute, so tools text attribute, so we have an actual text right here. So, looks good so far. The last thing we need is another view with input element click, match parent, background is selectable item background. This background here makes the view, if you click on it, makes it like, it's not that easy to describe, but it's that if you click this, you can see this animation in the background where, yeah, you can see that something was selected. It's a default Android animation. And just type in question mark and then selectable item background. Android clickable and Android focusable is important because by default views are not clickable. They are just clickable if you add these two attributes here or set a click listener manually. But we're not gonna set a click listener for this one. So we need clickable and focusable true on this view. So now we're almost done. What else can I tell you? The relative layout is filled from the lowest layer to the highest layer. So it means this view, or it will start with adding this view, then this view is added on the top of this view, then this view is added on the top of this view, and this view is added on the top of the next one. So it means this one is the highest. You can see this also in the preview. If I remove this one and add it here, oh, it's not that good to see. But now you can see the icon is above the number. And if I just redo this, you can see the number is above the icon. So means the lower you go in this layout here, the more you are on the bottom, the more on the top the views are. Oh, I don't know if you got that. This was explained really complicated, but I think you got the point. So this one is the view on the lowest part, and this is the view on the highest part. So right now we have our calculator input view layout already there. What we need right now is custom attributes, because we want to set the number or icon for every view by custom. What we do right now is click on values, new values resources file, and then we call this one attributes or ATTRS. What we are going to add here is a declare stylable for our calculator output view. No, not for our calculator output view. We need to create our calculator input view first. Calculator input view. Just do the same thing. This is a relative layout in our case. We also need to set context, attribute set, just pass this one, context, attribute set, great, just give me a second, right here. And then of course we want to say init, inflate the layout. So I just copy this one so it's gonna be faster. Just inflate it like we already did on the other view. Just inflate the calculator input layout inside the relative layout. So what we can do right now is, oh, I didn't know if I already told you, if you click on command on the Mac and then click on this layout file here, it's gonna open the layout so you can switch faster between two things. What we are going to do right here is make this one merge again. I told you in the last tutorial or in the last lecture about the calculator output view, how to do this and why we do this. Then we say parent tag, it's a relative layout in this case, and looks good so far. Great. Then we can say or open, this was actually quite fast, I hope you got it. This is the calculator input view. It just inflates the layout. This is the layout we just created. And then go back to the attribute file we just created some minutes ago, and then type in calculator input view. And then just like this. Okay. So now we are going to add attributes. What does that mean? That means that these are attributes we can set for our custom view later. I'm going to explain that later to you if I can actually show you something. I think that's easier for you to understand then. So next we're going to add item text. Format is of course a string. And we're going to add an attribute item icon. And the format is not an integer or anything else. It's a reference. What does reference means? Reference means that it's gonna reference to something else, like a color or a drawable or a graphic, whatever, like another resource we have in the app. So that's already it. Now we can go to the calculator input view again, and then we can say read attribute set. Then we say attribute set dot we say run, of course, run. So what does that mean? This attribute set can be null. So if a null is passed for the attribute set, we need to check this one first. And this one here is checking, okay, is the attribute set null? And this run is only called if the attribute set is not null. So if it's null, we just skip this one from here to here. This is not called, but if the attribute set is not null, this one here is called. So then we say we need to use a typed array. This is actually not that good to use. It's really old. I think since Android started, since the lower APIs, this hasn't changed. Yeah, there might be some changes in the future because this is not a good way to do this, because it's not that easy, and it's yeah, it takes a lot of time, or more time than you expect it to do. And yeah, but we need to do it right there like this because we can't do it another way, and that's why we continue right now. We say obtain styled attribute set, and then we say attribute set, and then we say r.stylable dot calculator input view. That's the stylable we just created here. This is a stylable. You can see here, declare stylable, we are declaring it, and right here we are calling it. There's a warning here that this typed array should be recycled, but yeah, we're gonna handle this one later. Then we say text resource is typed array dot get string, and then we say r.stylable dot calculator stylable dot calculator calculator text. So this is the attribute we defined here, and it's a string, so we need to call get string. Next one is the icon resource is typed array dot get resource ID r.stylable dot calculator icon, and in this case here, like you can see here, we need to set a default value. So if this resource does not exist or was not set, a default value will be passed. In our case, we will just add -1. Not minus minus, just minus. Great. Then we say when, a when statement. So what does a when statement mean? Do? It's gonna call for conditions. I'm gonna tell you that in a second. Just wait. Icon resource is the best way is if I do it with simple if statements and convert it to a when statement later. That's the best way for you to learn it. So we say if icon resource is not equal to -1. What does that mean? That means that if the icon resource is actually an icon resource and not the default value, -1, then we say input element image. So what is this? This is the ID we set right here. So if you use another ID, just use the other ID right here. And then we can say visibility equals visible, or just wait. We say text dot visibility is gone. What does that mean? That means that if the icon resource is not null, we are not displaying the text, so we are hiding the text. So we say set the visibility to gone, and then we say visibility dot element image dot apply, and then we set the visibility of this. So everything inside this block here is applied to this view. So we don't need to type input element image dot visibility equals visible and input, wait a second, input element image dot set image resource and then icon resource. So if we don't want to do this one, we can just use this apply block here and paste this one here and then just remove this one. So we just say apply and everything inside this one is applied to this view. I don't know if you got this, but probably you will understand a little bit. So what are we doing if the icon resource is set, so it's not -1? Then we say we are hiding the text and then make the icon resource visible and set the actual image. Then we say else if text resource is not or is null not or empty, and then we're gonna say add this one here. So we say like if the text resource is not null or empty. So means, can we use it? Just let me check. It's gonna be true if it's null, or it's gonna be true if it's empty. Okay, yeah, that we can use this one. So we are saying if it's not null and not empty, then we want to say input element image dot visibility is gone, because if this view has a text, then we don't want to display an image, we just want to display the text. So we say input element text dot apply again. We set the visibility to visible, and we can just set text equals text resource. Great. What is wrong with this? Okay. Then we add another else branch. So we say if I'm gonna just wait a second. I'm just thinking. I can't think and type at the same moment. Element image. So what does that mean right now? If the icon resource is not -1, so an image icon resource is set, then we are hiding the text and showing the image. Else if means only if this one is not true. So if this one is false, this one can be called. But if this one is true, all of these statements here are ignored. So only if this one is not true, the next one is checked. If I would do it like this, then this one would be checked and this one would be checked too. Doesn't matter how this one, if this one was true or not. But if we use an else if, means if this one was true, none of these else branches are called. And if this was not true, the next one is called. So again, what are we doing? We're checking the image resource. If it's not null, we're going to display the image. Else if the text resource is not null or empty, we are displaying the text and hiding the image. And else, so if there is no text set and no icon set, then we just hide all elements and It's just an empty element there. So the next thing we are gonna do is say typed array, typed array dot recycle, and then this error or this warning here will be removed. So what else can we do? We can also use a when statement. When is almost the same like an if else. So we say when icon resource is not null. And then we add this arrow. Oh, not here. So no, still not. Right, now I have it. And then I can say it's not that nice right here. So, and the last one, we just add another else branch. So, oh, just like this. What is wrong with this one? Oh, it's not on the correct place. So right now it's working. This is the when statement. So we are just checking like when, if this one is true, the when statement is removed. Not removed. So this is like the if else. It's checking if the icon resource is not null, and then this thing in this block here is called, and then of course we need to no, we don't need to do anything else. We're just, this one is called. If this one is true, then this one is called. If this one is true and else, this one is called. So it's like the if else statement, but it's, I think it's a little bit more, you can see it better, and if someone else is looking at it, you can just, yeah, take a look and easier understand what is happening here. So, and I think that's almost it. No, what we need to do is just type in on click listener, set on click listener. So what we need to do right here is input element click dot set on click listener, and then we just pass this one. What does that mean? If someone is using our view and is setting a on click listener to our view, then the click listener is not set to the relative layout, it's set to our clickable view we defined above right here. So like if someone is clicking this relative layout here, the click is just passed to this one here, so we have this selectable item background. So you understand why we do this. That's almost it. In the activity main, we can just add our first calculator input view. I will just copy paste it again, or just use calculator input view. Then we say layout width is, for example, like 64 pixel. Layout height can be, or also 64 pixel right now. And then the next thing is we say constraint, or I will just copy this one. Just wait a second. Oh no, I can't copy this one. Constraint start to start of parent and top to top of parent. This should be enough, I think. Yep. Oh, of course not. The top constraint top to bottom of ID, and then we say, oh, we don't actually have an ID yet for this one. We're gonna give this one an ID and call it not input layout, output layout ID output layout, and then we say output layout right here. So what does that mean? That means it's on the left side and it's below the output layout right here. We can see there is already a view, but it's not visible, or it has nothing inside. So what is the next thing we're gonna add? We say app, and then app icon, or what did I call it? I call it item text, for example. And if I type in 1, you can see nothing is happening. If I use the icon drawable trash, for example, there's nothing happening. Okay, I actually don't know why there's nothing happening. Maybe because we need to build it first. Just let me wait. Just let it wait. Yeah, okay, we just need to build it. That's my fault. Now you can see it has the background we want. It has the icon we just selected here. And if we now say item text, for example, and type in 1, we can see there's a 1 in it. If we type in a 2, there's a 2 in it. We can also just type in ABC and there's ABC in it. That's how we want it to be. And if we say icon and we use, for example, color accent, the icon is just a color. It can also be a color, or we can just use the IC plus or IC minus. Whatever, everything is possible right here. So you can set an icon and a text. But if you do both, for example, 1, you can see there's just the image. If I remove this one, then there's 1. But the icon has a higher priority. That's because of this when statement. The icon resource is, so it's checking, like it's gonna read these attributes here. It's checking, okay, the icon resource is not null, and then it's not gonna set the text because the icon resource is already set. So if you do both, the icon resource is preferred. Preferenced, not preferred. So yeah, that's it. So we created our first custom view. In the next, on one of the next lectures, we are going to learn how to place views inside a constraint layout. Then I will explain what these here, these attributes, and also these attributes here, mean. And we are going to place multiple calculator input views next to each other, and gonna have the layout you have, yeah, an actual calculator looks like. So in the next step, we're gonna have the actual calculator layout. If we play this one in the, place these views in the constraint layout. But yeah, that's like I already told you, is a thing for one of the next videos. So we are gonna see each other there, and have a nice day and goodbye. Hello and welcome back again to this lecture. Right now we are going to talk about the constraint layout. In general, what is the constraint layout? The constraint layout is a view group, just like the linear layout, or for example the relative layout. We already talked about the linear layout in our custom views. In the linear layout, the childs, the views inside, are just aligned vertically or horizontally in order next to each other. In the constraint layout, you can set the position of the view's top, bottom, left, right, start, end, whatever. And then the view knows, okay, on this position I should be placed or positioned. We already did these two, or we already added these two views to our constraint layout. I told you I'm going to explain to you how this is working, or why this is working later. And this is the moment right now where I'm going to tell you what these constraints here mean. So we have here layout constraint end to end of. What does that mean? That means that this view here has an end, of course, has a right side. And the right side of this view should be to the right side, to the end of the parent. So the parent is matching the parent. Oh, this sounds some kind of awkward, but the parent, the constraint layout is matching the parent, and this view end should also be at the parent's end, which means that the right side of this view is also on the end of the layout. Constraint start to start off means that the start of this view should be at the start of the parent layout, of the constraint layout, so on the left side here, which means that this view is as wide as the parent, because its start is at the parent start and its end is at the parent's end. And here layout constraint top to top of parent means that its top is to the top of the parent. So what this actually means, these three constraints here, that the fuse start is on the left side, its fuse end is on the right side, and its fuse top it's on the top. So it means it's just placed, yeah, like you can see here in the layout. The next one is the calculator input view we already added. We have just two constraints in here. The start to the start of the parent, which means that it should be aligned on the left side. We could also say start to end of parent. Oh, this makes no sense, sorry. We need to say end to end of parent. Now it would be right aligned because the fuse end is at the end of the parent right now. But of course we want to have the view on the left side. That's why we say constraint start. The start of the view is to the start of the parent. And then we have the constraint top to the bottom of our layout. So what does that mean? We have this layout here. This is our output layout. And the top of our view here should be to the bottom of the other layout. So means these layouts bottom is here. So this view's top is also here because it's aligned to the bottom of the other view. So shouldn't be that complicated until yet, I think. We are going to continue with the next view. The next is the key 7. We have a text in here. Item text should be, oh, what I also need to tell you is that you don't need to copy this one. I'm going to attach you a text file where you can just copy the whole layout here, because it would take too much time, too much time to do everything in here and to explain everything to you. So I'm going to explain this to you by one row, by 5 input views, and I hope you got understanding then what these constraint means. And yeah, it's just repeating each time more or less. So I'm going to explain to you how this works, and then you should get an understanding and yeah, can just copy this layout. So sit down, relax, take a look, try to understand, and then you can copy the other layout or do it by yourself if you can, of course. You can try, but if you don't get it or you're making a mistake, then just copy the layout from the attached file to this lecture. So this is key 7. We can say, okay, key 7 is right here. We don't want key 7 to be here. Why is key 7 here? Because we say that the top of this layout should be to the bottom of the output layout. So that's why it's placed here. If we replace this output layout with our key clear right now, then you can see, oh, cool, this view is below the key clear, because that's what we just told it to be. Then what we can add right now here is that we say that its bottom, or no, we are going to do that later. Just add the next input view. This should be key number 4 with the text number 4 should be below key 7. Yeah, not that complicated yet, I know. This is key 1 with text 1 and should be below key 4. This is key percentage with the percentage symbol and should be below key 1. So looks good right now. So we have our 5 keys over here, but what you can see is, oh, this does not look like it should look. Why? Why is this one not aligned to the bottom? Because we did not tell the view where its bottom should be. We just say that the start should be at the start and the top should be below key 1. But we didn't say, oh, where should the bottom be? That's what we are going to do right now. We say bottom to bottom of parent. So now this fuse bottom is at the bottom of the parent. But you can see, oh, this does not look good. Why is it? Why is it like that? Because this view is the only one that knows where its bottom should be. This one here has no idea, oh, where should my bottom be? It just know, okay, my top is at this position. I'm 64 pixel height, so my bottom is at this position right here, plus 64 pixel. So that's why we add a bottom constraint, and the bottom should be to the top of the percentage key. So it means that this view knows, okay, my bottom is at where the top of the calculator input view percentage key is. Same for here. The bottom should be to the top of the key 1. Bottom to top of key 4. Bottom to top of key 7. So now you can see it's centered right here. It's aligned correctly, but the size is still not correctly. Why? Because we are setting an absolute height. We're saying, okay, view, you are exactly 64 pixels height, but we don't want that right now. So we just set it to 0. And then you can see, oh, now it's fitting the screen, but not like we want it, because this, and this view is still 64 pixel height. So if we say 0 pixel, 0 pixel, 0 pixel, and 0 pixel, then you can see every view has the same size. We know this view knows, okay, my top is to the top of, my bottom is to the bottom of the parent, sorry. And this view know, okay, my top is here at this position below the calculator output view. And then all other views are aligned between these two views here. So that's how we made it. That's how we got a completely row of the calculator. We could just add another view, just one last view. Gonna add that from scratch. We just say calculator input view. This one still has an absolute width. And we are going to add an absolute height for this one. We're gonna remove that later. The icon is the key divide. Not the key, the icon divide. We have, or we need an ID for this one, key divide. And then we can say top to bottom of our output layout. So we can see, oh, okay, right now it's on the correct position. But now we need to say start. Should not be to the start of the parent, it should be to the end of our key, how do we call that one? Key clear. So right now this view is added at the end of key clear. And yeah, that's how we made it. Sorry. We could just add the other views right here, then replace the height again with a 0 pixel and set all constraints. At the end, you need to have 4 constraints for each views. One for the start, one for the end, one for the top, and one for the bottom. We don't have a constraint end right here, because this only makes sense if we have all views in here. But you will see that in the final layout. I'm going to copy this one and paste it here. Just remove these. Oh, of course I should also copy it. What's the problem in here? I don't get it. It's not finding some ideas, but the ID should be there. I don't know why, maybe I need to build it. But this should work right now. We should see the actual layout in here. And yeah, it's not working. Just let me take a look why it's not working. I'm gonna talk to you in a second. So I'm back here. I actually don't know what was wrong with this layout. Probably just a formattation issue. I just restarted Android Studio and now it's working. So this is our layout right here. You can just copy this layout from the attached file to this lecture. And then what you need to do is replace your package name, this package name with your package name. And then it should look like this and it should work. So you could right now start your app, just select the calculator app, and then you could run it on an emulator or on an actual device, and then just click run. And then you should see an actual calculator app. It is not working right now because we have not implemented any logical parts yet, but you should see this UI here if you start the app, and you should be able to click something. Of course, nothing is happening like I already said, but you should be able to see something and click something. And yeah, isn't that great to have your first visible UI elements there? So we are going to make this one work with actual logical parts in one of the next lectures. And until then, see you and goodbye. Hello and welcome back. In this lecture, we are actually running our app for the first time. Maybe you're excited because you haven't seen this app before. Right now, you're going to see what you created so far. We only need 2 steps for this one. We need to select a configuration. If you have multiple modules inside your project, then you can also select different configuration or just create new configurations. It's not important for you right now. There should only be one. I don't know why there is a second one here. This is also not a valid configuration. I can remove that. So just select the calculator configuration, and then you need to select a device on which you want to run your app. So if you plug in your own Android phone, it should appear right here. But what you need to do first is to enable USB debugging. I'm not gonna explain how this is or how you enable USB debugging. You can Google that or use another search engine. And yeah, find out. You need to enable USB debugging on your device, enable developer options, and then enable USB debugging. And then if you plug in your phone or tablet, it should appear in this list. We are going to use an emulator for our case. An emulator is just like a virtual device on your computer, which is, yeah, more or less like an actual phone or tablet. So you shouldn't have any emulators in your list right now. I already have. This is actually not an iPad. It's just an Android tablet with the screen resolution and the destiny of an iPad. That's why I call it iPad Air and iPad Pro. So you can't create Apple emulators on Android Studio, of course. So what you need to do is open AVD Manager, click on Create New Virtual Device, and then you can select here, you can select tablets, here you can select phones. We are going to select the Pixel 3a XL. It doesn't matter which phone you select, it should run on every phone right here. Just select one of them, click on Next. Then you can select or need to select a system image, and yeah, just select the latest one. In my case, it's API level 29. Maybe if you are watching this tutorial, it's a newer API level. It doesn't matter which API level you select. You can also select older versions, but at least 21, because 21 is our minimum API. So if you select a system image lower than API 21, our app wouldn't run on this phone. Just select the newest one, click on Next, then you can set a name for your device, and you can set the startup orientation here. And what is also interesting for you is device frame here. You can enable the device frame, it's enabled by default in this case here. What does that mean? It means that your emulator, which is displayed, has a device frame. If you unselect this one, just the display there will just be the display and no frame around the display. Yeah, we can enable it or disable it. It doesn't matter. It makes no difference. And yeah, here are also some advanced settings. Yeah, you can set the RAM, for example, or set an external SD card, or just import your custom skin. Whatever, doesn't matter. We don't need that one, so just give it a name, select a phone, an Android image, And yeah, then we can continue, click on finish. Then our device should be created. And then we can click on this run button right here. And I can drag it over here. So our phone is started. We need to wait for a second. But the phone should be booted really fast. So it's almost done. There it is. We have an actual phone here. We don't have an actual phone here, but we have a virtual phone here. AVD is Android virtual device. So we can, yeah, this acts like a normal Android phone. And we can just run our app on this one. So go back to Android Studio, close this window, and then we can select this. I click on this run symbol here. Then our app is compiled. You can see here it's assembling debug. It's doing some tasks. Gradle is doing some tasks. And if Gradle is done, it's installing the app. You can go to your device or to your emulator. And here we see it. Great. We have our calculator app. We can click. Yeah, we can do something. Nothing has happened because we haven't implemented any logical parts yet. But we can see our actual app. Doesn't it look great? I think so. But what does not look so great is this green toolbar and green status bar here. We don't want that one. For this one, just open the resource folder, values folder, and then open the styles attribute. And in this case here, we have our theme with an action bar, and we just replace this one with no action bar because we don't want an action bar in our app. So if we run it right now, you can just click Control and R. So letter R to run our application. Now our new application is running, and we can see there is no toolbar right now because we just remove it. The status bar does not look that good with the green color, so we are going to change our status bar color. Just add a new item. Okay. Name is, I don't know what he's doing. Oh, of course, because I'm not in the style. Sorry. Go inside the style, inside the add theme, then add a item, and then set status bar color. And then we just want to set our status bar color to black. Add a new comment. Set black status bar color. And if we run it right now by clicking Control and R, or just this symbol here, you can also click this one. So we can see here, black status bar, looks great so far. If I click on this one, you can see the app is relaunched. This is also working. I think this is hot swap or something like this. Oh no, it's just because it already is running, then the symbol is changed. I think this was coming with one of the latest Android Studio updates because I didn't saw that until yet. And yeah, just click this one to run your app again if you change something, and then it is restarted. So great. Here we can see our calculator app. Nothing is happening like I already told you because we haven't implemented any logical parts yet. That's what we are going to do in the next lectures. And yeah, I hope your app does look like this right now. And I will see you in one of the next lectures. Goodbye. Hello and welcome back again. In this lecture, we are going to talk about the Model View Presenter architecture. Just some real basics like what is Model View Presenter, why do we use it, how do we use it, why is it in general there. So we start with the problem. If we have a really simple view that is recognizing some input, doing some basic logical operations and displaying some output, we don't have a problem. For example, this could be a button you can click, then a number is increased, and then a text view is displaying the current number. And if you click the button for 3 times, for example, then a 3 is displayed. If you click it 2 more times, a 5 is displayed. Really simple. Yeah, we don't actually need something else. We can do it like this. And yeah, that's how we're gonna do it. But if we now have an advanced view, it's in most cases not actually a view, it's an activity, for example, or fragment, something more complex, which is, for example, recognizing multiple inputs, doing some logical operations like calculating, storing something inside a database, communicating with a REST API, or in general storing states and displaying multiple outputs, we have a problem. Because if we just had one view and would do everything, recognizing input, doing logical operations and displaying output inside one view, there would be thousands of lines of code. I don't want to be the one who works on this one, because yeah, you don't have that overview. You don't know, oh, it's too much lines of code and you don't know where should I start, where should I do what. You change something on point A and then this automatically changes something on point C, D, E, F, G. Whatever. I don't want to work on a file that has thousands of lines of code. Another second important point is that if everything is inside one file and one view, the view is destroyed, everything is deleted, everything is gone. So, for example, if you have some states like the current equation in our example, or the current outcome, this would be gone. So the new view does not know, okay, what was the old equation, what was the old outcome. Also, if you're communicating with a database or a REST API, maybe you need to reload that database with a new view and reconnect to the REST API, for example. So that's what we don't want, because this takes time, this takes resources, and this is not good practice. So we don't do that. What is the solution? The solution is Model View Presenter. In the Model View Presenter architecture, we just have one view that is recognizing input and displaying output, but has no logical operations in it. That's what the presenter is for. The presenter is doing the logical operations like calculating or storing states. And then we have the third part, the model, that is, managing data. I will talk about that on the next slide. First, we're gonna say the view is recognizing input, like I was clicked, is telling this to the presenter, hey, I was clicked. Then the presenter can calculate something, for example, and then setting some output like, okay, set the text now. Like I already told you, on this page, we are going to, I'm gonna explain you what each of the parts does, what it is responsible for. The model is managing data, for example, databases, REST API, etc. This is not that important in our case because we don't have a database or a REST API. The presenter controls all logic about the view, and there is no context or framework specific object. There is no context or are no framework specific objects inside the presenter. Why? Because of testing. It's not that easy to test actual framework classes, but it's easy to test Kotlin classes, for example. And the view is the actual visible element. It contains no logic, it has no brain. It just passes all inputs to the presenter and is completely controlled by the presenter. So in our case here, we don't have a model like I already told you, so we are just working with the view and the presenter. Here you can see multiple events like on solve button clicked, on plus button clicked, on minus button clicked, on 1, 2, 3 clicked. Whatever, the view is just saying, okay, on 1 was clicked. Then the presenter recognizing, okay, the view says on 1 was clicked, I'm going to do something, whatever, edit, do something, do some calculation. And then the presenter says, okay, view, now update the equation and update the outcome text. So the view doesn't have no brain, like I already said. The view is just passing all events, like on plus button was clicked or on 1 was clicked to the presenter. The presenter is doing some calculation and then says, okay, view, now set the equation text or now set the outcome text. Why do we use it? We use it for view state independence. So a big point is, like I already said, if you have everything in one view and it's destroyed, we don't have any logic states, we don't have anything stored, we don't have anything that is still there, because if it's destroyed, it's completely gone. And in this case here, we have a view1. We're gonna attach that view1 to the presenter, doing some stuff like typing in 1 plus 1, and the presenter knows, okay, our current equation is 1 plus 1, our current outcome is 2. So now, for example, on orientation changed is called. This is what happens if you rotate your phone. And then the old view, the view1, is destroyed, and the landscape layout is loaded, and a new view is created, the new landscape layout. So then we can just say, okay, our view2, we're gonna attach this to the presenter. The presenter still knows, okay, our current equation was 1 plus 1, our current outcome was 2, and can tell the view, okay, here, just display this outcome, display this equation. So the presenter is storing all logic states, and it's not depending on the views. We can just destroy a view and attach a new view. This is no problem. The presenter still stores all logical states. Next point is testing without starting the actual app. So what most developers or many developers do is just opening the app and then test something, like type in 1 plus 1 equals, and then the presenter should, or the app should say 2. Okay. But if you just have like 3 tests, a person can just type in, okay, 1 plus 1 is 2, correct. 2 plus 2 is 4, correct. 3 plus 3 is 6, correct. Okay, easy. But what if you want to test like 100 different equations, or maybe more complex equations? This would be a problem. If you need to type in everything every time you change something, this would take hours or maybe days to test everything. And this is why we use unit tests. A unit test is just a simple test that is testing, in this case here, 1 plus 1 equals 2. Really basic, but you write that unit test once, and you can just run it again and again and again. So in this case, we are going to attach our mock view to the actual presenter object, to a real presenter object. Then we say real presenter object, just add 1. Like a 1 was clicked, we are doing like, okay, 1 was clicked. And we can then test, then the mock view should set the equation to 1, because that's what we want the presenter to do. If we add a plus and add another 1, then we say, okay, presenter, we just typed in 1 plus 1. Now, what are you going to do? And then we say, okay, then our mock view should set the equation to 1 plus 1. Okay, working, great. And then our mock view should set the outcome to 2. And so you can write multiple tests, like hundreds or maybe thousands of unit tests with different equations, and can check if the presenter is doing everything correctly. And you just write that test once, and then you can run it again. So if you change something, for example, if you're done with your project, and then like half a year later, you are going to change something inside the presenter, inside the calculator presenter. And then you open your app, test something, test some basic equations, and say, oh, everything is working, great. Then you say, okay, I'm done, cool. But suddenly there's an error, there's an issue, because there was one case that is not really gonna happen, but can happen. And if this case can happen, or does actually happens, then you have the problem. And if you have unit tests, you can just cover so many different cases and just need to run. So you change something inside the presenter half a year later, then you run the unit tests. You can say, okay, 99 unit tests passed, but 1 failed. So you can see, oh, okay, looks like I broke something. Maybe I need to do it a different way because this is not actually working. And that's the good thing about unit tests. You just write them once, and then you can just run it again and again every time you change something, and can be sure, okay, the presenter is still working correctly. That's why we use Model View Presenter to test our app completely without actually starting it. This is an actual test. Our test here is called 1 plus 1 is 2. Like you already saw on the graphic before, we attach our view, we add 1, add a plus, add another 1, and then we test that our view should set the equation and set the outcome correctly. So we are going to do something like this in one of the next lectures, but that's it for now. We have everything done here, And yeah, now you should have some basic knowledge about Model View Presenter. What is it? How does it work? And why do we use it? And in one of the next lectures, we are going to implement the actual Model View Presenter architecture inside an actual view. So, hope to see you there. And yeah, have a nice day. Goodbye. Hello and welcome back again to one of the final lectures. Right now we are going to implement the actual MVP architecture to our calculator app for the calculator output view. So you already learned some theory about Model View Presenter, and now we are going to apply something practical and apply this theory you already learned to our calculator app. So first, what we need to do first is open our build.gradle file. You can also find it here, the calculator app. And we need to add a new dependency. It's this one right here. We use this for the actual calculation. It's a library where you can execute JavaScript, and then we can just execute some basic logical calculation operations. That's why we need this library for. Then click on sync now. Then everything should work fine. And the progress should finish. Gradle sync should be done. Great. We can remove this one. So what we are going to do next is to create a package for our calculator output view. It doesn't matter how we call this. I'm just calling it calculator. You can also call it calculator output view or whatever. Just make a custom package because these views have something to do with, these classes have something to do with each other, and that's why we place it inside one package. Then we take the output view and drag it onto the calculator package, and then just refactor, and now it's inside here. So we already have our calculator output view. Now we are going to create a new Kotlin file class and call this one calculator output interface view. So, and this is an interface, of course. And we need exactly 2 methods for this interface. This interface in general is the interface between the view and the presenter. So we are going to add 2 methods here. We say set equation with the actual equation as a string. And we say set outcome also as a string. So this is the interface on which the presenter is calling, and then the presenter can send or set some stuff to the view. So the presenter can set the equation and set the outcome. Yeah, you're gonna see what this one is used for later, I think. Then I can explain it better. So what we need right now as the third and last class is the presenter. So calculator output presenter. Okay. So this is not a class, this is an object. So we call this one object calculator output presenter. What's the difference between a class and an object? You can instantiate multiple objects or multiple instances of a class, but an object is a singleton. That means that you only can have one of these objects. So there cannot be multiple objects. Like for example here in our output view, or the best example is if you open the activity main, inside our layout folder, we have multiple calculator input views. We have 1, 2, 3, 4, 5, and so on. So we have multiple instances of the same class. So this is one class here, the calculator input view, but we have multiple instances right here. But for this calculator output presenter, for this object here, there can only be one instance. So you instantiate it once and then it's always there. And there cannot be multiple objects and instances of this type. There can only be one. So that's why we use object. So what is important? We need to store our view. So we say private var our view, and our view is the calculator output interface view. And this can be nullable, is null by default. Then we have two methods, the attach method, calculator output interface view, and then we say our view is the view. And we have the detach method where we don't need a parameter for this one. We just reset our view and set it to null. So that's it right now. What we can do right now in our calculator output view is we call the unattached to window. We can say calculator, so right now, calculator output presenter dot attach, and then we say this, and on detached from window, we say calculator output presenter dot detach. But should we actually use? Yeah, that's the correct one. So you see here, this one is still red underlined because we don't extend this interface. What we need to do right now is to add this interface, calculator output interface view. Then you can click option and return, and then implement members, and then implement both of them. So what we have done right now, so our view is now implementing the calculator output interface view. So this interface here is implemented by our view. So means we can just attach our view now to the presenter because this view implements this interface view. And these are the methods here of the interface view. And what we could already do, of course, is So if you open the layout of the calculator output view, we have our two text views here. We have our input equation and our outcome. And then we can right now just paste this calculator input equation, and then we say dot text equals equation. And the other one is the calculator input outcome dot text equals outcome. So great. Now we say if the presenter is setting the equation here, is calling this set equation method, then we are updating the actual equation text here. And if the presenter is calling the set outcome method here, then our view is setting the outcome. So we attached the view to the presenter on the window attached to window method. We detach the view from the presenter on the detached from window method, and we are setting the equation and set the outcome. Great. What we need to do to add right now is the add, remove, clear, and resolve, no, it's only solve method. So we just add a new method, which is called add item, where the item is a string. We have a method that is calling remove item, and a method that is calling solve, and a method that is calling clear. So that's it. We don't need more methods. Our view can add a new item, like a 1, for example, or a plus or whatever. Everything is an item. We can remove an item. If you click on the remove button, then the last item is removed. We can solve the equation if we click on the equal symbol in our calculator, and we can clear the whole equation if we click on that trash symbol. Then everything is clear. So what we need to add in our presenter right now is the some more method. We say fun add item is a string. We say remove. We can also say, oh, of course we can also say solve, and we can also say clear, because like we already learned, the view is just passing all events to the presenter and has no logical operations, no logical part, no brain. So that's why we just pass this one to the calculator output presenter dot add, and then we pass our item. In this one we say calculator output presenter dot remove, calculator output presenter dot solve, and then we say calculator output presenter dot clear. So that's it for the view already, because we have everything in the view right now. You can see we are recognizing inputs, like add item is an input, for example, for that view. We're saying, okay, add this view can add an item or remove an item, for example. And then this method or this event is just passed to the presenter. And then the presenter can say, oh, it can't right now. The presenter can say, because we are attaching it here, the presenter can say set equation or set outcome, and then the view is updating the outcome. So this is for recognizing input here, and this is displaying output. This is attaching the view to the presenter to the view. No, the view to the presenter, sorry. And this is the init method for initializing. That's it. So we already have completed our calculator output view. Now we need to keep on working at the presenter. So what else do we need? Some comments, for example, current attached view, because this is our view. And if we now call, for example, set equation, and then we say 1 plus 1, no, not 1 equals 1. So we need to add this question mark here because our view is nullable. So that's why we set it can be null. So that's why we need to add this question mark here. And yeah, so if we would do that, like this, we would write this line of code here inside the add method. Then we can say, okay, every time the add method is called, the view is setting the equation, and then 1 plus 1 is displayed. So every time add is called, 1 plus 1 is displayed. So this is what it would do right now. That's how we close the circle between the input, the presenter, and the output. So now we attach the view. We have our view here, and then we can just call methods on the view. But that would not make sense. So that's not why. That's why we're not doing it. We need some local variables right now. We need our current equation is a string and is by default empty. Oh, what have I done there? So is a string and is empty by default. What is also important is that you always write some comments to your, for example, states here, because like current equation is more or less says what this variable is storing, but it's always good to add another comment. So if someone else is working on this class here, has never seen it before, it's good if he can just read the comment here and see, okay, it's current equation, or this one here, oh, it's current attribute. Yeah, it's almost self-explaining in most cases, but better have one comment more than one comment that is missing, and so someone else does not know what a variable is for example. Then we need our current outcome, private var. I don't know if I have already explained the difference between val and var. So did we use val anywhere? I'm not sure. Okay, if we would type val here, this would be final. So that means if you type in val, this property, this view here, can never be changed again. So this is null and will always stay null. That's why it's giving an issue here. It says val cannot be reassigned. So you just assign a value once to a val variable, and then the val variable always have that value, and you can't change it anymore. If you have a var here, this means this is mutable, this variable, so it can be changed multiple times. You can just say, okay, now it's this view, now it's null, now it's another view, and now it's null again. You can just assign it again and again and again. That's the difference between var and val. And what else do we need? We need our interpreter. So in this case, we can make it a val, private val interpreter is a new interpreter, and make sure you use this one here, the BSH 1, because this is the stuff we implemented in the Gradle file. So this is the actual class that is doing the calculation here. So in the onAdd method, what are we going to do now? We are going to add two methods before we say update equation, and we add a method update outcome. So in the update equation method, we just say view.setEquation, and then we say our current equation, and in this case we say view.setOutcome, our current outcome. So every time we want to update the outcome, we just want to every time we want to update the outcome or the equation, we just need to call this method here, update equation, and then the current equation, or the current outcome in this case here, is sent to the view, and the view is updated every time we call this one of these methods here. So in the onAdd method, we just say our current equation equals our current equation, and then there's this plus method here in Kotlin, where you can just add another element to one element. So we just saying, okay, our current equation, for example, is 1 plus 1, and our new item is a new plus, another plus. So now we say our current equation is 1 plus 1 plus, and then the string element is a plus. So now this string here is added to this string at the end. So that's the simplest, the easiest way to explain that to you. Then of course we want to update the equation, we want to update the outcome, and we need another method, of course. We need the calculate outcome method. So every time we call this calculate outcome method, of course we want to update the equation, then we want to calculate the outcome and then update the outcome. We can also just, we can just make this one private, of course, this one also private, and this one also private. I have not said anything about private and public methods here. I'm going to do that right now. If you write nothing like this one, the method is public. So like, for example, you can see here, this is the view. And if I would say calculator up presenter dot calculate outcome here, it's possible because this method is public. I can call it from outside of the presenter. If I would give this one here a private prefix, it would say no, cannot access, it's private. And the method would not even be here because it's private and not available outside. So all methods with a private prefix here are only accessible inside this class here, inside this object, inside this presenter object, and not from outside. And all methods without anything are accessible from outside. Like you can see here, we can call this remove method here from outside, from the calculator output view. So because this is just internal, for internal use here inside this class, we can make this private. And yeah, I think that's it for the add part. Now we are going to add the remove part. Add the remove part sounds kind of funny. We say our current equation equals our current equation dot substring, and then we say null, and then length -1. So what does that do? This means that we're just removing the last letter or the last character from our current equation. So substring means that we create a new string from the equation and we start at position 0, so at the first letter, and go until the length, so the whole size, the last letter, -1. So it means we are removing the last one in this case here. If we would, for example, say -4, then the last 4 characters would be removed every time we remove something. You can just try this by yourself later and just take a look. Okay, what happens if I change something here? I'm not going to explain that so in detail. But what happens if the current equation was has just a length of 1? For example, there was just one letter, just one number, like a1 in there. If we would call this method, it would crash because he can't make a substring. Just think about the length is 1 because we only have one character. Then the substring would be from 0 to current equation put length was 1, -1 is 0. So it's making a substring from 0 to 0, which makes no sense. So we don't want that. That's why we are checking if, or let's outline that later, if current equation dot length is larger than 1. Then we want to do that, else we say our current equation is this one here. Oh. So why do we do that? Like I already told you, because if the size is larger than 1, so if there are at least 2 characters, then we say okay, then do the substring. And if there's only 1 character and we click on the remove button, then of course we can just clear it. Now he's saying here, assign and should be lifted out of if. What does that mean? That's a cool method or cool functionality in Kotlin. You can just click option and return and then lift assignment. So what does this mean here? We're just saying our current equation equals, and then we say if this is true, then we say our current equation equals this one. And if not, we say our current equation here equals this one. Cool thing, what we can already do is we can just like set our current view to null, for example. It makes no sense in this case, but we can just do some stuff here inside this method, or set our current outcome to 1 and then update the current equation in the last one. So the last line of this statement here is assigned to our current equation. For example, if I would set a 1 here, it would say it's not true because it's not a string. But if I now say toString, oh, I can't do that. But yeah, and the last line here of this statement is assigned to our current equation variable. So that's really really cool functionality in Kotlin. That's why we do it like this. It's easier, and I think also like you can see it better for people who are not working on this code. It's easier to understand what is happening right here. Next thing is we want to update the equation, calculate the outcome, and then update the outcome. So on the solve button, we can say if our current outcome is not empty, so means that there's something inside our current outcome, like 4 or 5 or whatever, something, but not empty. Because if I type in 1 and a plus, this would be empty because there's no outcome currently. That's why we're checking if our current outcome is not empty. Then we say our current equation equals our current outcome, and our current outcome is resetted to an empty string. Then we update the equation and we update the outcome. So why do we do this? If we have typed in, for example, 1 plus 1, and then I can display or show you on the view here. So if this one is 7 multiplied by 7 and the outcome is 49, this is automatically displayed. And if I now click on the solve button on the equals symbol in the calculator, then the equation says 49 and the outcome is cleared. So the current outcome is moved to the equation, and then I can add like one more, for example, and then it says 50 in here. But that's what we want if we click on the solve button. And that's what we are doing here. If our current outcome is not empty, then our current equation is set to our current outcome, and our current outcome is set to empty, or is emptied. On the clear button, it's the most easiest thing here. We just set our equation to an empty string, set our outcome to an empty string, and then just update the equation and update the outcome. So that's it with the clear button. Yeah, the only thing left is to calculate the actual outcome. So what are we doing? We are checking if, so if our current equation dot is not empty. Why are we doing that? Because it would make no sense to calculate something if our equation is empty, our outcome is also empty. So that's why we check if it's empty, else we can say our outcome is empty, because if the equation is empty, our outcome is automatically also empty. Next step is we say interpreter.eval, and then we say result equals, and then our current equation. Result is interpreter dot get result, and then we say if our result is not null and our result is an integer, we can say that our current outcome equals result dot to string. I'm going to explain that to you in a second. And that's almost it. So what else we need to do is just cut out this one and add a try catch. So make this one in a try, and then we say exception E, and then we set our current outcome to empty. So what are we doing right now? We are checking if the equation is not empty, and if it's already empty, the outcome is of course also empty. If the equation is not empty, we are saying, okay, interpreter, just run our current equation. Then we are saying, okay, our result is the actual result. And then we are checking if the result is not null. And the result is an int. Then we say, okay, current outcome is the result. And this catch method here is called, for example, if we would type in 1 plus. So 1 plus is not a valid equation. And then this method here, this one, I think this one, yeah, this part here would cause an exception. And that's why we call this catch. So what this method is actually doing, this try catch, is trying to execute some code. And if this code is failing or causing exceptions, then the catch method here is called and it's just continuing. If you would not do that inside a try catch, the app would crash because of the exception. But if you're handling the exception, it's like, okay, please try something. If this gives an exception, do something else. And if not, just run this code inside this one here. Then it's okay. So this is what you do with this try catch if you're not sure if the operation you want to do is working, or if it's throwing an exception. And that's why you use a try catch block here. So in this try block, we are trying to resolve our current equation. This is just one of the libraries, so I can explain this one to you in detail. It's the library we implemented at the beginning of this video. And yeah, it's just working like this. You type in result equals our current equation, and then we are getting the result. And yeah, just setting it. But I think that's it. That's all for it right now. So this should be everything, I think. I haven't forgot anything. I hope so. It's not working right now because we are not adding or removing item. That's what we are going to do in one of the next lectures. But in the next lecture, we are going to write some unit tests, and then we can check if the presenter is working before we connect the view or the actual visible elements, the 1 plus and so on, to the presenter. We can just test if the presenter is working by a unit test. But that's a part for the next lecture. Hope to see you there, and have a nice day, and goodbye. Hello and welcome back. In this lecture, we are going to write our first unit test for the presenter we just created in the lecture before. So what you can do right now is, I need to just close all these resource folders here. You can open the package here with test, not the Android test, the one with test, then remove that example unit tests, or right click, and then click on, oh no, there it is, delete the one, and then right click, new Java Kotlin file class, calculator output test. So then we say class calculator output test. And of course, what we need is our presenter. So we just say presenter equals the calculator output presenter. Calculator output presenter, there it is. And then we need a mock view, private val, or just call this one view, not mock view. We say mockito dot mock, and then we say calculator output interface view class.java. So in the build.gradle file. I already showed it to you multiple times, but what we need right now is this one here, this JUnit library and the Mockito library here. So these two libraries are necessary for the testing right now. If you have not already added them, then just copy them, add them to your dependencies inside your Gradle file, and then click on sync, and then everything here should work. The next thing is we add an add and a test annotation, and then we say fun, and you can just call this one like 1 + 1, for example. So it's working. But what is cool in Kotlin is what's cool in Kotlin is that you can just call methods with a space, at least for tests. Like we can say 1 + 1 is 2. This here is, oh, it's hard to describe. It's not the default, yeah, I don't know. If you already used GitHub or in general Markdown language, it's the symbol in which you can highlight code. Also in Slack or some other applications, you can use this one here to highlight code. I don't know what this one is called, but if you want to get the symbol and don't know where to find it on your keyboard, just type in a search engine Markdown highlight code, and then you will find this symbol here. So we can just call this 1 + 1 is 2, or if you don't want to search for this symbol here for this one, just call this test like 1 + 1, for example, or whatever. It doesn't matter. This is also a valid name. It makes no difference what's the function's name. So just decide for one of them. But what we are going to do right now is that we say presenter.attach our mock view. Yeah, just call this one mock view. I think it's better. Mock view, attach our mock view. And then we write some comments. What I do is we say given that the view is attached. Then we can say when, and then we say then. So this is a typical part of a test. You say given, so these are the requirements for the test. So this is what needs to be given. Then you say when, so when you do something, then something should happen. So you say given that, for example, the sun is yellow, and when I move the moon in front of the sun, then the sun color should be red, for example, or black, or whatever. So it's the given, when, then principle in the testing. So we say when we add a 1, presenter.add a 1, a number is added, then we say then, just import it, then our mock view should set the equation to 1. Oh, not to this one, to 1. Then the correct equation should be set. So this should already work. If we click on run right here, it's running the test, or should run the test in just a second. Take some time to compile. And the test is passing. Great. So right now, if we type in here a 2, for example, and run this test again, the test is failing. It says set equation 2, but the actual one was 1. So we expected the equation to be 2, but the actual equation was 1. So we can say, okay, something is not working. Of course, because if we add a 1, then the equation should be 1 and not 2. But there you can see, okay, the test is failing if the equation would not be set correctly. And if we add a 2, for example, then the test runs again because it's correct. So what does that mean? That means that the test is only as good as you wrote it. So you can't say, okay, I wrote like 100 tests. If the tests are not written good, then the tests don't work or do not secure a correct functionality of the presenter. So that's why you need to make sure that your tests are correct here. So like if I type in like, okay, I can't do something wrong here right now, but you can see, okay, the one is working. So also make it negative or try to make your test fail. For example, like typing in, see, okay, everything is working great. But what happens if I type in a 2 here? For example, you can see, okay, the test should fail. Okay, it is failing. Correct. Perfect. Now I can change it again. And yeah, I can also add multiple then when statements like given once here. And then we say when a number is added, then the equation should be set. When an operator is added, we say %dot_add a plus, for example, we can say then just copy this one, don't write it again. Then the correct equation should be set because the equation should be 1 plus. Run this test again. Great, it's working. Like a test, like what happens if I change this 1 to 1 minus. Test is failing. 1 minus was expected, but 1 plus was the actual outcome. So perfect, that's how we want it. And at a last part, when a new number is added, then the equation should be 1 plus 1. And also then the correct outcome should be set. Sorry. We say then our mock view should set the outcome to 2. Run this test. Great, it works. For example, set our outcome to 4. Run this test again. Now it should fail. Okay, 4 was expected, but okay, 1 was the actual outcome. Okay, that's because set equation or set outcome is called multiple times. Like you can see in the presenter here. If we add our first element, the first one, then update equation is called and update outcome is called. So the outcome is set to 1 here. Like we set the equation, but also set the outcome to 1. In the second case, we set the outcome to empty, and here we set the outcome to 2. So that's why the arguments here are not correctly, because this is called multiple times. But if you change it back to a number 2, you see it's working because this is actually called. So our first test is completed here. You could also write a second test, for example. You can just copy this one and then say 2 plus 2 minus 1 is 3. So we say 2, add a plus, add a 2. The equation should be set to 2, should be set to 2 plus 2. Then the outcome should be 4. If I add another operator right now, oh, that's not what I wanted. Where am I? Here am I. So if I add another operator, then the equation should be 2 plus, this one should be a minus, 2 plus 2 minus. And if I add another number, when a number is added, another one, then the equation should be 2 plus 2 minus 1. And the outcome should be 3. So, should work right now. Give it a try. Perfect. If we type in a 5, for example, the test should fail. Great, it's failing. Says 5 was expected, but 5 was not there. So that's why we change it back to 3. Now it's working. Oops. So we already have 2 tests written, 2 plus 2 minus 1 and 3, and 1 plus 1 is 2. You can also write more complex tests and then, yeah, can check if your presenter is working correctly. So just write many unit tests to make sure everything is working correctly. Like I already said, the testing is only as good as you do it. So like if you write these 2 tests, for example, yeah, you don't actually need unit tests because, yeah, you could also test that in the actual app. It's faster, just type in 1 plus 1 or type in 2 plus 2 minus 1 and check it. But for example, for more complex equations like 1 plus 1 minus 3 divided by 5 and so on, where multiple calculation operations are performed, this is what is more complex, and this is what you want to test in your unit tests. And like I said, you just write them once and then just click on run, and then it's running all tests. Okay, why is this one failing? Have I changed something? Didn't. This one runs, and if I run it on all, it's not running anymore. Okay, don't ask me why. This is not working. Normally you should just run, or you can just click on run this one here, and then it's running all unit tests, and then everything is done. I can't actually tell you why this is working if I test it here, and is not working if I test it here. I don't know what's the difference. I could just take a small look. Okay, it says wanted is this one, but what we actually have is this one. Oh, of course. Yeah, the problem is that we set the outcome to 2 here and our equation to 1 plus 1, and we are not clearing it. That's really important. Oh, good that I have taken a look at it. So clear the presenter. What is really important is that we say presenter dot clear. We need to clear the equation, and we need to clear the equation and the outcome after every test. Because if we are not doing that, then because the presenter is stateless, it's surviving, or it is not destroyed, means that the first test is running, and then the current equation is 1 plus 1, and the next equation is 2. Or the next equation, sorry. The current equation is 1 plus 1, and the outcome is 2. And on the next test here, if we attach our view, the current equation is still 1 plus 1, and the outcome is 2, because we have not resetted it. And that's why the test isn't working anymore. So now it should work. So great. So you could just run all your tests. You just write them once, like write 100 tests in here, or maybe do multiple classes for your tests, and then just click on run, and everything is running, and you can see, okay, is everything working anymore? So that's a great way to test your app. I can just say do it like this. It's so important to test everything, because I already saw it so many times that some developers just changed a small thing somewhere. Everything seems to work fine, and then like sometime later, like half a year later or whatever, then suddenly, oh, this is not working anymore. When did that happen? I don't know. And the tests are here to detect when something like this happens. And yeah, that's why you should always write tests and use the MVP architecture to make testing possible. So that's it for this lecture. We just wrote our first test. You can write some more tests if you want, of course, just to practice by yourself. Just, yeah, add a new test, do something, try if everything is working correctly. I haven't tested this interpreter here. Yeah, really good. So might be that there might be some issues. It might be possible that there are some issues with this interpreter. Maybe you find out if something is not working. So just write tests and yeah, check out if this interpreter is working correctly. So yeah, but that's actually it. So have a nice day. See you in one of the next lectures where we are finally bringing everything together and making the app work. And until then, goodbye. Hello and welcome back. We are finally here in one of the final lectures to bring everything together and make the app, the calculator app, actually work. So in the last lecture, we created the calculator output presenter, and we have written some tests to make sure that the presenter is working. And right now we are actually implementing the calculator output view and the calculator input views and connect everything. And then the app is actually working. So the only thing we need to do, it's not that much, is just to set on click listeners for each input view here. That's actually it. So what we are going to do first is start with the keys and not with the numbers, or with the number. It doesn't matter actually. We can also start with the numbers. If he just says here, okay, I can do, we can say set on click listener, set on click listener, and then we just say output layout dot, and then we say add item, and we add a 0, of course, on key 0. We can just do it like this. So if you now press command and letter D, you can just duplicate it. And so we just say 3, 4, 5, 6, 7, 8, 9. I don't know if I counted correctly, but just change this one to key 1, key 2, key 3, 4, 5, 6, 7, yeah, I forgot one, 8, and then key 9. Now we need to import everything. We can just say key 1, 2, 3. It's faster than importing everything by ourselves. So 6, 7, 8, and 9. I think we could import every key, but it doesn't matter. So key 9 is missing, so now we have key 9. Great. So we only need to set the actual numbers we are going to pass to the presenter. So now we have all numbers in there, and what we can see right now, if we start the app, just select your configuration here and select an emulator here, and then just run it. I started my emulator, so it's already there. And the app is starting, and what can we see right now? Great, we can type in numbers. Brilliant. Keys are not working right now because we haven't set an on-click listener yet. So just numbers, but we can type in numbers. Great. Looks good so far. Yeah, no numbers were no keys working, but that's what we are going to implement next. So we say key clear, set on click listener, and we say output layout dot clear because we want to clear everything. Then just double it again. We have our key divide. On key divide, we want to add a divide character. Then there's key multiply. On multiply, we want to add a multiply character. Same thing for, did I call it plus? Or key add? Key add, we want a plus character, and Did I call this one remove? Yep, I did. We add a minus character. So what else is missing? We have the clear, these. So the remove one is missing. So now we can say, like, maybe here, key remove dot set on click listener output layout dot remove item, and the key solve, or how did I call that? Resolve? No, key equals. Yeah, key equal. We say output layout dot solve. So I think we should have every button. We have 1, 2, 3, 4, 7 here. 1, 2, 3, 4, 7 here. Great. And if we now run our app, we can, or we should see that everything is working. I hope so, but it should work correctly because we already tested the presenter with our unit tests. So we are still waiting. Create build is running. So now installing, restarting the app. And here we can see our actual calculator app. So we can use operators. Solve button is not working right now. Minus is also not working. Why is minus not working? Output layout dot add item. Oh, because we used the wrong key right now. Key. Oh, which one is it? Here. Key minus. Key minus. So that's probably why it did not work. So right now we should see dividing is working, minus is working, plus multiplied by 8 is working. Great. Only the solve button isn't working. We can take a look at that. The remove button is working and the clear button is also working. So let's check out why the solve method here is not working. We can debug it right now. So we can just type in some numbers, 99, and then we can click the equal. Now we can see he's jumping into this one here. Now we can type in current equation is correct. Then we say our current outcome is also correct. So now, oh, we say is not empty here. So is not empty is what we want right here, because he's not going inside, because the current outcome is not empty, so he's not updating it. So just restart the app again, and now it should work if we replace this is empty with is not empty. 88 minus 99, for example, equals great, working. So you just learned some basic debugging, how you use it, and yeah. So the actual calculator app is working. That's great. You can calculate some stuff, type in some stuff. Oh, the percentage. We forgot the percentage key completely. So we can just say key percentage or key percent. We want to add a percent character. Start it again. And now everything should work fine. I think now we have every character in there. Great. Works perfectly. So, okay. This makes no sense right now. So we can add an operator or multiple operators. This is what you can maybe improve. You can just say, okay, you can check here in the presenter, add an item. You can check, okay, if the current equation already has an operator character, you can just say, okay, do not add it. If it has no character operator, you can add it. You can just, yeah, improve this calculator app. Like I said, it's really basic, so not everything is working like it should, or perfectly everything is working like it should. But yeah, there's still some points that you can improve, of course. But yeah, in general, it's working great. So we did our first calculator app. But what we see right now, if we rotate our phone, nothing happens because we disabled rotating probably on this device. Yeah, rotating. If we rotate our phone right now, you can see, oh, okay, does not look that good. In this case, it's okay, but on some devices, on my personal phone, for example, something is cut off and you can't see everything. So this is not a good layout for landscape mode, and we want a different layout for landscape mode, but that's what I'm going to explain you in the next lecture, the landscape layout lecture. And until then, have a nice day, have a nice time, see you, and goodbye. Hello and welcome back to the final lecture. So this is the last lecture for this course. What we will just do, it's just really simple, is add a landscape layout for our app. So it's not just rotating the actual layout, it's actually having a custom layout for landscape mode, like you already saw in the last video. So we start with right clicking here on the layout folder, click on new layout resource file, and then we say activity main. It's just important that this is the same name as the current main layout. So if you call your activity, for example, activity home or activity 1 or whatever, make sure that this name is the same as the other one. Root element can be a linear layout, that's correct. And now the important part, we select this orientation part here and click on these arrows and then say landscape. And then you can click OK. And what you see right now is we have two layouts. This is the layout for the default mode for the portrait mode. And this is the layout for the landscape mode. So what we do is horizontal orientation in here. Then we can go to our main activity layout, copy the calculator output view, right click copy, and then just paste it. We can remove this app flags here, set the height to match parent, and the width to 0 pixel. So you see, now it's gone. But what are we adding right now is layout weight and set it to 1. And now we can see, okay, it's fitting the whole screen. I'm going to tell you something about the layout weight. If we add the next view, just copy the whole layout here from the bottom to the top. Just copy the whole constraint layout and add it also. Then we need to, or we can remove this thing here and the output layout. It's important that we remove the calculator output view because we already have it over here. So just remove this one. And now we have the problem that this constraint isn't available anymore because we have no output layout. So we are replacing this one with top to top of parent. And there are 3 more lines of code that we need to change. Just go through your layout and check for them. So now it's looking good. Or actually it's not looking good because we can also remove this one here. So what we need to do, of course, is we say 0 pixel here, and then we say Android layout weight is also 1. So what we can see right now is that these two layouts here, the calculator output view and our constraint layout, have the same size. They are 50% of the layout width. This is because of the weight here. So if I change the weight of the right view here of our layout to 2, for example, you can see it's split in 3 parts. this view here has 2 parts and the other view has 1 part. So altogether it's 3 parts. This is 1 out of the 3 and this is 2 out of the 3 parts. So you could also change it like 4 and then it's 4 in general, completely it's 4 parts, and this has 1 part and this has 3 parts of the whole thing. But we want both things to be the same size, so we changed this one to 1. We could also set it to 0.1 for example, and this one to 0.1. It wouldn't make any difference because it's just adding all of the weights together. Here's the weight. All of the weights together and then making it percentage, or calculating the percentage and then set the width. So just set both of them to 1. Now we can see, okay, we have the correct layout here. And then we can just run it on our emulator. And what we should see right now is that the landscape layout is loaded. Great. But there's an issue right now. If I type in 88, for example, multiply by 8, and then rotate the phone, you can see, okay, now it's gone. There's nothing visible anymore. But if I type in A1, you can see, okay, the old equation was stored, but it was just not displayed. And that's what we want to do right now. We want everything to be displayed, and that's a part and a task for the calculator output presenter. Inside the onAttach view, we say update equation and update outcome. So every time a new view attaches to the view, to the presenter, we say, okay, view, just update or just set the equation and set the outcome. So just go to the presenter, open the presenter. Inside the attach method, we say, okay, a new view is attached right now, then update the equation. So the current equation is set to the view, and update outcome, the current outcome is set to the view. If we start this right now, you should see that if we type in something and then rotate our phone, it's still there. Great. Perfectly. So now we have a completely working calculator with a landscape layout. If I rotate it back, you can see, okay, there's still an 85 displayed. So we finally did it. We have a calculator app. We have developed a completely working calculator app with a landscape layout and the model view presenter architecture. So I hope you had fun. I hope you liked this course. Just let me know if there's something that I can improve. And yeah, hope to see you again, maybe on another course. And until then, have a nice time, have a nice day, and goodbye.